Okay, so the next problem in the lead code we are solving is longest increasing subsequence. Okay, so basically longest strictly increasing subsequence. Let's try to understand what does it even mean, right? So basically when it says strictly increasing, it means that it's not should not be even equal. Actually here we can say, right, this is sorted, correct? It's an ascending order sorted. So but we can say it's not strictly increasing, correct? When you say strictly increasing, it should not be even equal actually. 7 8, right? That's a strictly increasing, like that's not equal. If you take 7 7, it's not it's a sorted order, but it's not strictly sorted, I can say, right? Because that's like, I mean, there are same numbers in it. Okay, so that's what strictly increasing mean. Okay, now let's try to understand what is subsequence. Okay, subsequence, or you there is also a term called substring, right? Subarray, right? In the terms of array, it's a subarray. Okay, let's try to understand what is subarray first. Okay, subarray is nothing but any part of the array, like it should be in a continuous way, that's it. Okay, 2537 is a substring subarray, right? And 7 118 is a subarray. Okay, now what is subsequence meaning? You can either delete or for one of the index that are in between, yeah, at least one. Okay, or you can actually zero also. Okay, you can if you take an example, right, 257 is a subsequence. We didn't change an order should be same, but it may or may not be like all the indexes are present in between. Okay, that is a subsequence. So but the order should not be changed. I cannot what does it mean is 259 is not a subsequence, right? It's not a, like, I mean, we are changing the order here, it's not a subsequence. Okay, it should be in a same order, but one of the, if it is missing any of the indexes, right, that should be fine. Okay, so it is like all subarrays are subsequence. Okay, like let's say that 253 is a subarray, correct? It can also be subsequence. Here we didn't deleted any subsequence actually, but it's not the other way around. So what I mean is, let's say that 257 is a subsequence, correct? We deleted this 3. Okay, but so for a subarray we should not be the case. 253 should also be there. Okay, now we understood what is the difference between subarray and subsequence. Now let's try to understand like how we can solve this problem, correct? So let's try with an example. Let me Okay, so let's say that I have taken this example. Okay, so we need to find out a longest increasing sub length. Okay, so let's say that if I am starting from here, right, I will identify the strictly increasing subsequence basically. So if I start from 5, okay, I will start here, and 4 is decreasing, right? I will not take this. Okay, I will not take this, and I simply go to 6 1. Okay, I will go to same 6, and this is increasing than the previous one. I will consider it. So the length is 2 now. I can go here. Length is 3 now. I go here. Length is 4 now, and there is nothing else. So the max length is 4, right? This is it, right? So but what we need to do here is one more catch here is, so let me write one more example. We cannot simply do like this. We'll have to try out different combination. Let me write one other example. Okay, so in this example, right, I've just inserted the 15 here. Okay, we just inserted this value. Let's see now. Now let's try to analyze with whatever the logic we did so far. So I will start with 15. Okay, so if I start with 15, so I will go to the next number. This is my increasing number, right? 15. It is increasing, but for all the next numbers with the whatever the logic we followed, we will not be satisfied. Correct? 15 is there. It is lesser than 4. I mean, 15. 4 is lesser than 15. Will not take it. Will not take it. 6 also will not take, because it is lesser than 15, lesser than 15, lesser than 15, lesser than 15. So in this case, what happened? Longest strictly increasing subsequence, the length has resulted in 2. Why it returned into, like, I mean, so it's like what it mean is, like, I mean, instead of we pick the wrong number here, right? To find out a correct one, we should have gone to directly to 6 actually. So this one we should have gone to 6, correct? So in that case, what would have got the result is 5 6 7 8. The length will be 4. That is the correct answer. See, these are the two values. Okay, length is equal to 2 is also valid, length is equal to 4 is also valid. So what we need here is the maximum length, correct? So this is the one. Okay, so we cannot, what I mean to say is, we cannot simply keep one number and try one combination and we are done. No, what we have to do here is, we'll have to try this one. This is also valid one, but next we'll have to try the next numbers. So it is like, let's say that if I pick this one, right, first time I will go this side. Okay, the next time I will have to go this side. I mean again this one. Okay, so once you're done with this, you will also have to solve the subarrays now. Okay, subarrays. This is like, so we are trying to solve it brute force way, and we cannot, like, I mean, it will be like too much, like, I mean, too much time complexity it will be having, as we are trying to duplicate too many things, right, like, I mean, I will be going to 15 here, and again I will be going to checking here. I'll be checking here. I will be checking here, right? So what's happening here, it is a too much of duplicate task here. So let's say that if I pick 14, right, let me clear it out. Okay, so as we saw before, right, I have a two possibilities. One is I can go to 15 or I can go to 4, correct? There are two possibilities here, correct? So every time I do it, obviously, like after doing this calculation, what I will be doing, I will be going to some other calculate, some other, the same numbers, right? I will be checking for this one or some checking for this one, and I will be checking for 7, correct? So I will also do the same for 4 and 7, right? Like when if I take this path also, I will be going and checking for 7. If I going for this one also, I'll be going and checking for 7. Okay, this will not be the good way. Once again, let me pick the number 16 here. Okay, let me pick a number 16, that will make it the more clear. Okay, so let's say that if I pick this number also, I will be going to the 16, correct, because that is greater than the 15. And if I go to this path, right, for 6 1 5 6, again also I will also go to that same path. So what does it indicate here is, so every time I solve this, I will have to go to 16, like whichever the path I took, I will actually going to the 16 path, right? So it means that we are trying to duplicate, we are duplicating our efforts here, like we are doing the calculations again and again, right? So how to avoid it and how to efficiently solve this problem now. Okay, so let's say that if I already done this calculation, let's say that I found out, let's currently what we are trying to do, we are starting from 5, correct? We are starting from 5 and we are trying the combination for each of them. Next I will try 4, I will 6 7 8, correct? So instead of doing that, let's say that I will do it from the end, and let's store this value somewhere. Okay, let's store this value somewhere, so that what will happen is if I go this way, right, 5 15, and once I reach there, I can simply use that value, because I already know for this one what will be the calculation, right? So whatever the calculation we do, right, we already stored it somewhere, we can simply read it, correct? So anytime I go there, I will be having that value ready, right? I don't have to recalculate again and again, right? So that's why what we can do here is, let me clear this out again. Okay, so what we'll do is, let's try to calculate from backside this time. Okay, and store it some, as we know, right, as we are talking here, we are trying to store some value. Okay, store it and reuse it. What are we simply doing? We can say it says that we are storing it in a cache, okay, or a memorization, we can say. And when we are saying that it's a cache and we are reusing it, it is nothing but a dynamic programming, correct? So what we do in generally in dynamic programming, we'll initialize the array, okay, dp array, like where we are going to store our results. Okay, so what we said is, so let's process it from the end, so that we will be already having this value. So whenever we need, we can read that value. That is the idea here. Okay, so for every time, if I am here, right, like I mean, what is the strictly increasing number for this one? Let's say that if I am starting from here, what will be the maximum length value? So this will be always 1, right? This will be 1, there is nothing left, so we can simply say 1, right? Or else what I can say is, let's say there is number called 3 in the array. What is the strictly increasing for this one? The answer is 1, correct? There is only one element, so the answer will be 1. So simply for 8, right, there is nothing left in the end, so we can simply assume that it has a 1. Okay, for the next one, what we'll have to do here is, we'll have to find out all the greater number. Okay, like we'll have to identify, like this is 7, right? We'll have to find out what is the formula that we are going to follow here is, will whatever the number that are next to it, right, currently we are solving for 7, we'll look for all the elements that are greater than this. Because what is happening here, so here 5, right, sorry, here if I pick this 5, I will also have to consider this also. I will also have to consider 16 6 also, correct? I don't, it's not like okay, 7 is 8, I can directly read the value from here, correct? I will also read the value from this also. So what we will have to do here is, we will fetch all the maximum numbers that are available next to it. Okay, so that is one thing. So once we got all the maximum numbers, because we need only maximum numbers, we don't need minimum numbers here, right? So that's why we are not considering, that is it actually. Okay, so once we got all the maximum numbers, we'll read the value, like I mean, in the dp array we have already stored it, correct? So we have already stored the value for each of them. Like I mean, let's say if there are some numbers, right, like for we might have, currently we have stored only one. Like let's say if there are many numbers, right, let's say 1 2 1, so we'll fetch these values and see which is maximum, like I mean, which will give us the maximum result. Okay, so we will pick that and update it to our this array. Okay, we already, like I mean, standalone, this already has a 1, correct? Like length is 1, whatever the element that comes next to it, right, like whatever that we pick from the dp array, that we will also add it and update it here. Currently 7 and 8, right? So what is the greater element that is here presented to the 7? Only one element. Okay, which is, what is the dp status of this? This is 1. So what will be the 1? It will be the current will be 1. And what is the result that we are reading from dp? That will be 1. So answer will be 2. Yeah, okay, so next we'll take for 6 1, and we'll do the same thing. What is the, how many number of max elements are there? There are two max elements. Okay, there are two max elements, and what are their values? what are their values currently. If you take standalone 6, it will be already we have 1. Okay, let's try to check for the next one. Actually 7 and 8, we have two numbers that are greater than 6. What are its values? 2 and 1, which is the maximum one. So I should not go for 8, right? I should be like, I mean, I can simply pick the 7, right? This already has it. So this is the maximum number, so we are going to pick this one. So what it will be now? 3. Okay, similarly now if I go to 4, all the 6, 7, 8 all are strictly increasing here, right? So 1 will be there because for any number 1 will be the answer. Okay, so that will be there. We'll have to check now. 6, 7, 8 are all are maximum greater than the 4. Okay, we'll have to check the maximum of all of this. What is the maximum all of this? This will be 3. So answer will be 1 plus 3 will be 4. For this number, what does it actually mean is, this is the, like, I mean, 4 will be the longest strictly increasing subsequence if we start from 4. Okay, that's what it means actually. So if I start from 15, what will happen? There is no number which is less greater than this one. So what will happen? It already has that one thing. Okay, do you find anything greater than? No. So we will not find anything in the subsequence also, like in the DPR also. So it will be 0, so it will be 1. Okay, finally we'll come to 5 now. So what will happen here? For 5, it already has that one thing. Okay, 1 plus, we'll see like any all the greater number. This is greater, correct? 6 is also greater, 7 is also greater, 8 is also greater. So we'll have to pick this one. Let me highlight in a different color. We'll have to pick this one, and greater element is this one and this one, right? I'm just mapping it, this one. Okay, 5 is greater than 5, 6. These elements are greater than 5. Okay, so out of this I will have to pick that number that will be the maximum one. Okay, so this is the greater one, correct? So we'll have to just add this one. 1 plus 3, 5, 4. So how does it, like, I mean, this is the efficient way, right? So as we saw before, if I go to 515, so it will be resulting me to only 2, right? That is strictly 2. But now with this approach, we are directly picking the maximum values that you can yield, correct? So this time what we'll do is we'll directly jump to 6. Okay, so this is the maximum value. So it already identified the 3 strict increasing, so this will be the result. So ultimately what we'll do is we'll find out the what is the maximum value. Okay, like out of this in this DPRA, we have stored the all the strictly increasing subsequence, right? The length. So we'll calculate what is the maximum value and return it. Okay, now quickly check the solution. So what do we do is, so first we'll say that result is equal to 1. Okay, because in a, if even if it is an this one, right, like one array, so it's actually at least we'll be having one array. Okay, so that's why we can say confidently say that result is 1. If it is an empty, this won't be the case, right? So let's say that initially we'll initialize it to 1 for now. Okay, and then let's initialize the DP array, and default value we can set it to 1, because let's say that for any of the element, answer will be 1, right? So even though if it could not find any strictly increasing element, we can simply say its answer is 1. So let's initialize that array with the 1 value. Okay, and the next thing is, what we'll have to do is, we'll have to start processing from the end, correct? So will be, this is the range for reversing, and you don't have to process the last element also, correct? It's always 1. There is nothing left in to process, so you can just simply say 1, correct? So that's why we are skipping it. Or else you can also keep n minus 1. That will also work. It will this loop will not run in that case. Okay, so we'll be coming from backside. Okay, and inside will be like whatever the element we are here, right? Let's say that we are traversing from here, and at this point in time I'm checking the value for this one. Okay, so I is pointing to this, j will be doing the calculation for this range. Okay, the next to it, we'll be checking all the greater numbers, and we'll be getting their corresponding longest length that was already calculated. Okay, so this is the j, and this is the I. In the j, the next available element, it will I is equal to point into 6. We'll pick all the elements that are next to it, and we'll see like which are the elements that are greater to it. Okay, and whichever the element will greater to it, and there we'll be calculating, like, I mean, we'll be finding the maximum DPRA status which is longer. Okay, so we'll set that. Okay, ultimately once we are done calculating, checking for everything, we'll set it to the result. Okay, and we'll have to add it actually, because as we said, right? So 1 plus, this is, we should not forget this, because this is the number, right? For everything this is already 1. So whatever the element that comes next, right, it's like kind of addition. Okay, if we couldn't find it, it's a 0. if it is there, we'll have to add it, right? So that's why we'll have to make sure that we in the DP array we have already initialized it to 1, so that's why it is just an increment adding it. Or else you can, if you initialize the DP array to 0, right, what you will have to do here is 1 plus whatever the next maximum value that you got. Okay, and either what you can do here is, instead of initializing the result, right, you can simply say max of longest, whichever is the maximum, right, that you can do. Or y2, like I mean iterate again, and right, so you can simply initialize it once and use it like this also. Yeah, that's it. I think the this video length has become, like I mean, kind of increasing, so I mean kind of big. So to summarize here, what we are doing here is, basically we can solve this, like I mean there can be like too many of iteration we are be doing. Okay, too many iterations we'll be doing, and we'll be doing the same duplicate operation. Okay, let me clear this out actually. Okay, yeah. So this is the, if this is the array, so basically we will be trying out each of this combination. Like we'll be picking the 5 first, and then 4, and this will be one flow we'll be doing. And next time what we'll be doing, once we pick the 4, we'll actually will be doing this combination, and it will be like too many of combination that we'll be doing. And where we can see that most of the time we'll be hitting hitting the higher numbers again and again, again and again, right? So I mean, as we will be doing the recalculation every time. So to avoid this, what we have thought is, like we will do the calculation for this first and store it somewhere. Okay, so that every time I go there and hit it, so I can read it from the cache, so I don't have to recalculate the stuff. Okay, so that's how we decided that we'll have to processing from the back, not from the beginning. Okay, so we started processing from the back. So we did a calculation for we whatever the, like we already know for last one is 1. That's a straightforward thing. Or else okay, that's one thing. And whenever you pick for any element, right, from the this element, what you will have to do is pick all the greater elements, because we don't need the decreasing element, we need only strictly increasing. We will pick everything and its corresponding DP status. Okay, we already calculated it for it, right? We'll calculate it, and which is the maximum DP status, that will be picked for the next jumping. Okay, so that will be picked, and we'll be adding it to the current one. So current one already has a value 1, because that is the minimum value that one can have. If we can find something, some other number, right, if we could find some other number, it will be addition to it. Okay, if it couldn't find any number that is greater than this, it will be 0. So 1 will be, at least will be there for any of the number that will be there, and we'll be adding the number to it. Okay, so this is it actually. So just to save the operation, we decided to go with the DP. We store the status, we store it in a cache, and we decided that as we are hitting this number again and again, we thought of solving it from this direction. That's it. Thanks.